the number of poles multiplied by the denominator equal to so we can say, as we know this, we have to differentiate we have to differentiate ds, and we know ds is the denominator of the transfer function. Like I stated earlier, transfer function is equal to ns over ds. So since we have this k here, we can differentiate the ds, which is known as the poles, or it's known as the denominator of the polynomial of the transfer function. So let's take this off here. So we say the differentiate of ds is equal to, let's say, what was it, k squared, when it was s cube, sorry, it was s cube minus 8 squared minus 15s minus 15, sorry, 15 minus 15 equal to 0. So we can see k here, so we can say this k 3s squared minus 16 plus 16, because there's a minus k here, so the k here comes with a minus, so s squared so plus 15 equal to 0. Yeah, so we have to find the values of s here, so we can find k. So now we have to find k here. So we have to find, sorry, s. We have to find s. We have to find s first. So to find s, we have to use the general equation rule, which we all know as x is equal to plus b minus b root of b squared minus 4ac all to a. We can find this. We can say a here is 3, b here is 16, c here is 15. We put the values there, we get s1 equal to minus 1.21 and s2 equal to minus 4.12. So we found another poles here of the transfer function. Yeah, and we can see we cannot equate this. We can say s1 is equal to the break away point. Why is s1 the breakaway point? Because a breakaway point is a point where two real axis roots of loci or locus branches meet, then leave the real axis. So after we draw the graph and we have maybe 1.2 here, you understand why this is the breakaway point. So when we get to the graph and we are plotting all the points, we'll talk about the breakaway points then. Yeah, so let's go back. So we can say s is equal to 1.21 minus 1.21 plus, or s equal to minus 4.12. So we go back to the first equation again, which is 1 plus the characteristics equation, as we all know, which is equal to 0. So when you put into the equation and everything, you find that you get, if you differentiate it, you get this So there are so many ways of finding the value of k, but in my opinion, I find it a special way which we can find the value of k. Whenever you have an equation with a power of 3, we can say the inside multiplier, which we would denote as im, is equal to om, which is outside multiplier. Thank you. So what are the inside multipliers? Inside multipliers are the numbers inside the equation, which is 8 and 15. So 8 times 15 equal to outside, which is 1 here, and then 1 here, which is k. So 1 times k, which gives you 120 equal to k. So we found the value of k. So we can say k here is your control gain or controller gain. Yeah, so we can say a here is your controller gain. So we have to find the points of, again, we have to find the point of this plus k0. But now we know k equal to 120. So we say so we have to find the real roots. We have to find the real roots of the equation. So to find the real roots, we use the same method, or